Let's do it now. Yes, please. Let's start the tutorial now. Yes, please. Question number 1. Find the horizontal and vertical components of velocity vector in the given. You see, you have very simple, we have done it before, that x component is equal to vi or v cosine theta. This is given to you. Theta is 30 degree, velocity vector is 20 meter per second, so x component is v cosine theta. Simply you will get this one, and y component is v sine theta. You will get this one. Very easy, right? Now next question, please. Should I go to the next? Take your time.
Teacher,
Yes, please.
is this tutorial going to be uploaded in the Blackboard?
Sure.
Or should I buy it from the...
Sure, inshallah. Blackboard and YouTube on both sides. You will see.
So I'll get the link for this tutorial, right?
Sure. If you have subscribed my channel and you click the bell button, automatically it will give you the information that I have uploaded it.
Okay, check. So I will find these questions, right? Upload them. I will find the questions.
Right.
Upload them and solve them in my own time.
Inshallah. Next question, please. Yes.
Can you put the whole slide, the whole and the Blackboard?
Okay, inshallah. Later on, inshallah. Or we may be having some revision before the midterm, inshallah. Don't worry. Right. Second question, please. Question number 2. A cannon fired a shell with a velocity of 40. So this is Vi or V0 is 40 at an angle of 60 with the horizontal. Ignore the air resistance. Find the time taken to reach the maximum height. So you need, say, maximum time. Okay, so you know the maximum time you have to find out. And we have this equation, the first equation of motion, Vf is equal to Vi minus It. Since we're talking about, you know, the initial velocity of y component of the initial velocity, so Vi sine theta, this is V0 or Vi sine theta minus GT max. This is what we did already. vi0. You see, when you are going up, y velocity is decreasing, so it becomes 0 at maximum height. So y component is 0. So 40 sine 60 minus 9.8 t max. So you take this minus to the other side, it will become positive. Okay, and you do the mathematics, you will get this t 3.53. You can do it even with your calculator if you want. Yeah.
How can I know VY is 0?
Yeah. You see, you remember what I told you in the beginning of this projectile motion, two-dimensional motion, right? This is x-axis, and once you are going up like this one and then coming down, you see, as I told you, x velocity of the projectile remains the same throughout, even on the top, and y velocity is decreasing, and then it becomes 0 at maximum height. This is maximum height. At maximum height, Vy is 0. This is what I told you. Okay?
Okay.
Any question about this one, T max? Is it okay with you? 3.53? Right. B part then. Yes, 9.8 always.
Teacher,
Yes.
B, total time of flight for the shell.
Yeah.
T equal to T max is 3.53.
Yeah. Yeah.
Okay.
For example, you can write it here instead. So you can write 2 multiplied by 3.53, you will get 7 seconds. It is 7.06. We round it off 7 seconds, no problem.
Teacher, why don't we do Vx and dy?
Vx?
We do only, yeah.
Actually, we are doing whatever we are being asked. So if he asks Vx, we will do it. Right now in this question, he is not asking Vx.
So if it's Vx, we will do the same thing.
You see, Vx you use when you are talking about the x distance. Next part, C part, you see next. Now C part, find the horizontal distance, that is range, or the x you have to find out. Okay?
So we'll use the same rule.
Yeah. So this is T, not T max, because T max you use for vertical height, and total time you use for x distance. Get the point?
Yeah.
Because if you use T max for the x distance, that is wrong, because the T max is the time you are on the top. So for x distance, which is on the down, so you have to come down, so total time. So now this is x, or range, or delta x is vi cosine theta t, or this one. Okay? By the way, you have another rule for horizontal range, so you can do that one also. So one method, this one. And the second method for the range, for example, if you need it, for example, I'm using the same rule that was equal to vi square sine 2 theta over g. This is what we did, you remember? So if you use this rule, vi square 40 square sine of 2 multiplied by theta, how much? 60. So divided by 9.8, you will be getting the same answer, 140. So any correct rule you can use.
We can't use the same way we use it in V1, teacher.
Exactly.
We can't use it the same way.
So
Different.
this is different method. I write it second method.
If it was Vx, it will be different than this.
Yeah.
V1.
Yeah. Because what we did here, this is time. So if you use time value here, you find it, and finally we did it before. We did mathematics.
We can't use time in Vx, teacher.
Sorry?
We can't use time in Vx.
Yes.
And X.
Yeah.
Okay, nice.
Finish?
Yes.
Next, number 4. Question number 4. What is, you see, a bullet is fired with an initial velocity to 25 meter per second, angle 30 degree to the horizontal. What is the velocity in y direction? Mean you have to find out vertical velocity, and we have the rule for it, which is equal to Vy is equal to Vi sine theta t minus gt. Vy minus 2.2. Alas. You see, a bullet is fired with an initial velocity 25, angle 30 degree, okay, like this one. It will go like this one. Time 1.5 second. Okay, at this time 1.5 second, you have to find out its y velocity. We have this rule, Vi sine theta. In the beginning of the projectile motion, we discussed that the once you have this Vi, this is theta, this is Vx, and this is Vy. So Vy is equal to Vi sine theta. This is the initial component, Viy. Okay, so here you have Vy is equal to Viy sine theta. Okay, minus gt. Sorry, I made a mistake here. My mistake. Ignore my vi sine theta. Not here. Not here. Sorry, my mistake. Minus gt. Sorry. So it's okay now. Okay, vi sine theta minus gt. So viy, as I told you here, it is vi sine theta and minus gt.
What is minus 9.8?
Because we already, when we did equations of motion, we have vf is equal to vi plus at. We have delta x is equal to vit plus half at square, and the third equation also, this is x-axis, so we have y-axis. So whenever we have y-axis, we replace this a by minus, again this a by minus g, and delta x by delta y, and all these things. So we have y here. We did it in chapter number 2 in the beginning. Yeah. Sorry? G 9.8, yes. G always 9.8 meter per second.
Teacher, what about the tech? The tech group.
About?
The tech group, square.
Yes, you can write that one also. That was equal to vf square, vi square plus 2a delta x. So how we replace it? We replace this x by y and this a by minus g. These are the three rules. Right.
Teacher,
Yeah.
where should I find
It's there in the PowerPoint on the blackboard. In the beginning, we are giving the summary in the PowerPoint. You have two PowerPoints. Yeah, already there on the blackboard, please. Yeah. Sorry? We? Please speak loudly. Well, I cannot hear you. Oh, yes. Of course. When we use A and when we use G, huh? This is your question. When you are moving in along x-axis, you use A acceleration. When your motion is along y-axis, so you use G with negative sign.
So teacher, it's straight line, we use A.
Yes, straight line horizontal. And if you have vertical motion or moving, then you use instead of A, you use minus G. Yeah. Because right now, sorry, in this question, you have to find out the vertical velocity. So why? So that's why we're using minus gt, not at here. Vertical velocity you have to find out, because you are doing projectile motion, two-dimensional. Yes. Yes, please. Next question, please.
Teacher,
Yes.
when you upload the video in YouTube channel about the victims,
Again, please.
when you upload the YouTube channel video about the victims,
Today, inshallah, after this, in the evening, inshallah, night, Bad Maghrib, inshallah. It's already prepared, by the way. Start of chapter 2 and chapter 3 and today's lecture, inshallah, I will do. Don't worry, inshallah. Okay, and even then, if you have any other problem, you have the WhatsApp group, so you can ask anytime, discuss with your friends, and if still there is a problem, hadirin, la mushkila, inshallah.
teacher,
Yes, please.
can you send your channel like
Oh, why not? I would appreciate. Like and also press the bell button so that whenever I upload new, so you will get the notice. Okay, and share it with other friends also. I don't mind it. It's good, rather.
teacher?
Yes.
I have problem with my network, teacher. I enter maybe 3 or 5 times.
What?
I have problem in my network. I enter maybe 3 times.
Oh, so you have to buy some new strong internet.
No, yeah, teacher, I will. But what about this lecture?
Upload. You can see later on. Bukra, inshallah, you can see YouTube. Don't la mushkila. And even in the blackboard.
I think this teacher because I think this is my network now.
Inshallah, you'll see in the channel YouTube and also the blackboard recording also.
Teacher,
Let's. Sorry.
should I worry about attendance?
No, no, la mushkila. Don't worry about the attendance.
Okay, thank you, teacher.
Okay, leave it to me. Yes, please. Next question. Right. Next question, please. Yes, this is the next question. Okay. You see, you have two vectors. You have two vectors and you have to find out what resultant. So you have to find out, the resultant magnitude and direction, theta. Let me write it here. This is a vector for I minus 1j. We don't write 1, by the way. B is 2I plus 3j. You see, you have one vector, this one. I say this is I along x-axis, this is j positive, j negative. So 4I, so this is 1, 2, 3, 4. Okay, and then minus 1, minus 1, minus 2, minus, it's here almost. So this is your A vector, and B vector is 2I plus 3j. 2I, 1, 2, and 3j, 1 2 3, it's somewhere over here. This is b vector, so you have to find out the final vector. Easy method, I am telling you. Simply you are adding them, and once you add them you will get a resultant vector. Add them, 4 plus and 2 plus 6i, okay, plus 3 and minus 1 plus 2, okay. Now this is your resultant, mean your resultant is I there along positive x-axis and j here. So 2, 1 and 2 here, and go 6i, 1 2 3 4 5 6, it's here, and then go y-axis 2, so 1 and 2 here. So this is somewhere over here is your resultant. So this is your theta. Okay, now this is your resultant vector. Magnitude you can find out. I'm doing it here. Magnitude will be equal to Pythagoras theorem, rx square plus r y square. Okay, and rx square, how much rx? This is rx. So how will you write it? R is equal to rxi plus ryj. So this is 2, which is ry. This is 6, which is x component. So 6 square plus 2 square, you get 6.32. This is the magnitude, and the direction tan inverse ry by rx, 2 by 6. So you get this direction, which is 18.43 degree from positive x-axis. That's it. Yes. Always we did it in the in the last lecture, that when you have any vector like this one, for example, you have a vector, and you have this ax and a y vector components, x component, y component. This is theta, right? So magnitude you find out x component square by Pythagoras theorem, this one, and tan theta is equal to ay ax. This gives you theta is equal to tan inverse y component over x component. This is the way. Okay, this is how you find. This is magnitude and direction both. Now this is magnitude, and this is for direction, angle, I mean theta. Always, yes. Yeah. Watch people do wisely. Right. Next question, please. You see, you have a vector. I'll do it quickly now. This is a vector. This is b vector. Find a cross b and a cross b. Okay. Now, first of all, let me do a cross b. You know, we have done this when we did last lecture. X, Y, Z component. You see, now this is your a vector, this is ax. Ax is equal to 1 here, and y is equal to 2, like this one. So what we did, we can use, you know, leave it here. Okay, so you need the angle between the two. I'll leave it this one. Right. So we have here ax. This is ax. This is ay. Ax is equal to 1, and then bx. Bx is equal to 2 plus ay 1 by. This is by 2. Okay, z we don't have, so your answer is 2 plus 2, 4. Okay, now you see why I am doing this one, because I have this rule. You need theta to find out. So for this purpose you need a dot b. So a dot b I just finished 4. I would use a dot b4 here. Okay, let me write it here for you again. Okay, so this is for a, magnitude of a. You see, a is here. By Pythagoras theorem you can find out this one. A is equal to I plus j, 1i plus 1j. So a you can find out 1 square plus 1 square. So you will get 1.41. So I write here 1.41. Similarly, you have b is equal to 2i plus 2j. Again, Pythagoras theorem will give you bx square 2 square plus 2 square. So you would get 2.83 magnitude of b. So I write here magnitude of b 2.83 multiplied by cosine theta. So cosine theta, I take this one and this one here down. So 4 divided by, okay, so it will give you cosine theta is equal to 1, which will give you theta is equal to cosine inverse 1. You will get 0 degree. So theta you had to find out in the beginning, which is now 0 degree. Okay. Yes, we have last 5 minutes now. 7-8 minutes. So I have 2 questions quickly. Any question, please, up to here? Any question? Is it okay for you? Good.
Teacher,
Yes, please.
if it said in the question the angle between,
Yeah.
I used
You have to find out.
this one, right?
Yeah.
Only cosine.
Yeah, only theta you have to find out. Yes. Okay. So this is the rule. Dot or scalar product. A dot B we found 4. Scalar are the magnitude of A here. Magnitude of B is here. So we substitute here all these things and theta becomes this one. Next question, please. So you have lost these two last questions now. A scalar is a quantity. I have done already here for you. No direction for the scalar. Okay, a vector has magnitude and direction both. Projectile motion is an example of course, two-dimensional motion. Now AY is the vertical component of the vector. AX is, I have solved it here for you, horizontal component, magnitude of a vector, and this is scalar product or the dot product. Khalas. This is end of chapter 2 and its tutorial. So thank you very much and have a nice day. See you inshallah.